Top Gun here, clearing my throat at you to wake you up this morning, as you can tell by my splendiferous bedhead. This is early in the morning for me, and what has gotten my attention so early in the morning before I go to work that I have to get up with this bedhead and stank breath. Luckily, you can't smell it over the mic. I hope. Scratch and sniff YouTube. Worst invention ever. So, yeah, what brings me here today? Why? I mean, I love you guys. I'm always here for you. I don't know why you watch me. You seem to love me, so I'll give you the love back. I'm here for you. Why am I here today? What are we going to talk about in relation to Pulse? Because that's all you guys care about. Pulse products. Price go moon. Okay, so something new where, hey, are you a hex holder? Do you have a stake? Do you think, people should reward me for being smart and staking on top of just having that stake? Well, yeah, there are people giving out free airdrops. Be careful. Never give out your seed phrase. Beware of scams. That being said, what are we going to have a look at today? We're going to have a look at a meme coin, but more specifically than a meme coin. We're going to have a look at Solidity and smart contract reading today on this show. Why? Well, because a meme coin was released yesterday for, shall we call it 420 Relaxation Day, so I don't get busted by the algorithms. They released this meme coin. It's just a meme coin. It's like any of the other doggy coins. It's crap. But they recognize it's crap, like the one does that Elon likes to tweet about. So they're just saying, well, if there's going to be meme coins, might as well have our meme coin. So am I telling you to buy this meme coin? No. Did I buy any? No. But if you're a hex stakeholder, you can free claim. I mean, there's a little bit of gas involved. If gas rates are low, is it worth it for me to free claim? Well, when you interact with a contract, you're basically making a deal with the devil and signing in blood that they are allowed to take your firstborn child if they want. That is to say, the moment you click that agree, you get used to, well, at least I got used to through the 90s and the whole last, 25 years. You want to use our software? Please click accept and agree. Okay. All right. I click accept. I click agree. We can change our rights and terms at any time. Click accept. Click agree. This sounds kind of fishy. You mean this contract might as well be a blank check, and I am signing to endorse that you... That's how a lot of contracts work, because nobody ever wants to read them. So with the smart contract, it's kind of the same thing. You got to be careful what you sign, because it's an interaction of software, which means all those little lovely files in your wallet, all it takes is one line of code to say export, and your assets go elsewhere. Goodbye. This is why you must protect your seed, protect your security key. Your seed phrase is not actually your seed. These are two separate things, technically. You don't need to worry about the seed. That's embedded in the software code. You'll probably never get there. The seed phrase, the security key, that's what's important. Those 12 words, never give them out. And if you're going to sign a contract, make sure it's from software you're trusting. So RH, not going to bother reading those contracts. I've been working far too long. All my assets are that anyway. If he was going to rip me off, he had more than enough opportunity. Any other contracts I engage with? Well, I was a little concerned with how I was going to navigate this, because how do you trust a contract written in programming language? Well, apparently if you used to program in C++, HTML, and Java in the 90s, Solidity is not much of a stretch. I mean, yeah, some of the functions, I don't know how to code this and necessarily use it and structure it 100% right, but reading it to have the code tell me what it's performing and doing is pretty straightforward. So people were screaming with this Pulsedogecoin or Dogecoin. I don't know how you even want to pronounce that, but people are going, don't click on the smart contract. It will empty your address. And then somebody retorted, well, here's the smart contract. It should be safe. I can't read it. Can you? And so I read it. Apparently, I can. So we're going to go through a smart contract today and Solidity, and I'm going to explain a little bit on how to read a smart contract in Solidity. So the smart contract for this specifically, it starts and it says the programmer in Solidity 0.80. What's it doing? It's defining what language you're going to be using. So, the king's language. Art thou the greatest flower in all of the... Okay, still English. It doesn't sound quite the same, and there's something to be said for, mate, Cockney English is a bit different. Every English, it's all English, just bad English, good English. Every version where you have just a little bit of change to just the words like tubular, totally, that's an addition of English. Then, oh, so woke, and that's an addition of English. So these are new. Every English dictionary should have a V, 0 point whatever, as all the idioms in the language evolves. This is true for programming language, which means when you're using it, you have to say, oh yeah, I'm using this version that was created here. That way you understand everything I'm saying and there's no mishmash like the word gay. Go back to the 40s. Oh, you're so happy. Go to the 80s. Oh, well, they're not happy about that now. Say it now and people just, me? The word changes throughout time. So make sure your program can understand it simply enough. That's what this is. It dictates what language version and keeps it simple. So what does this tell us? It tells us we're going to execute an abstract contract. It's going to have a function from the message sender. We're going to need their address. And it's going to have a function with the message data. We're going to need that information. Please collect it. Moving along. By the way, now that you're collecting it, you're also collecting it in the same language. Again, Solidity 0.8.0. Okay. Then we have to have an interface for the ERC20, which is the interface for an Ethereum RC20 token. Okay. So first off, in that interface, then we have a function of total supply. And we'll have to have a return value. This will be listed as unit 256 going forward. So then it needs to return the amount owned by the account. So function balance off with the address account and external view return, again, of this unit 256, which means it's just bringing back the same value again. Okay. All right. This is how you start to add more English so you can read programming code. And look, this coder was so nice, he even dictated in simple terms in this grayed out text. Anything gray doesn't run. Anything in color runs. The grayed out tells you what the color does in case you're not sure, and then you can verify reading it. The function will transfer the address recipient this amount. External returns Boolean values. So that is how all information will transfer back and forth. The only thing that goes from the wallet address in this contract through to the contract address is the Boolean. In the Boolean, if you don't know, you're not old enough, a Boolean search was, how do I get my car clean? You type that into Google. Back in the day, it would be, how car clean? Maybe a plus symbol, some quotations for an exact word match. Boolean shortens things down into the data. That's all it is. It's just a format. Makes the values, if they're numerical, look more like they're in BedMass. No big deal. Okay. So then, to keep going here, to speed this up, because this is a long contract, I don't have all morning. It is available at this URL, github.com, pulse, or slash Pulsedogecoin, or whatever it is, slash Pulsedogecoin dash contract, slash blob, slash main, slash Pulsedogecoin dot sol for Solidity. So, anyways, looking at the functions here, what we're going to do is start going through them quickly. All right. So, we look at total supplies. We have functions for information, more information transfer. And then we have to approve. What was this for? Oh, yeah, looking for amounts. Indexed for amounts, indexed for owners and amounts. And then again, using the same program, it'll constantly keep saying programming Solidity language to make sure we're there. So this starts viewing returns of information, memory strings basically. Okay. Like all this stuff gets boring, but none of this is anything coming out of your wallet other than information. So again, keeping the balances private, keeping the addresses private, total supply, all that information gets returned. So basically the contract goes and it looks at your wallet and it says, "Hi wallet, why are you interacting with me? Are you allowed to? Are you a zero address? No? Great. Do you have any of these assets as in a hex stake? You do? Great. Now I can calculate your hex stake against this contract because you are owed some of this contract. This is where these values go back and forth and it does verifying. And then it says, you have this amount available to claim. Do you want to?" Okay, so this is simple information back and forth that is occurring in a simple order of operation. As I follow through this, like I can walk you through it step by step, but you're going to be bored and your eyes are going to gloss over. Basically, as we get through here, public operation, total supply balance off, total supply transfer, allowance, the approval. Here's the approval of the contract. Wow. Yeah, this gets so boring so much. So verifying recipient name, message sender, all information's correct as it's getting ready for an edit. This is just to make sure there's no problems. It's kind of error checking built into the contract. This is where it dictates it cannot come from the zero address. This is where it's putting in stipulations for things that would cause errors. It's nulling so an exploit, like, oops, you shouldn't be able to click that, but when you do, something funky happens because you shouldn't be able to click this. This says, no, you can't click it. Forget the word should. So in here eliminates a whole bunch of potential errors with the zero address. Basically when it comes to minting and burning, cannot be zero address or has to be zero address for different functions of the contract. And then we're back into Solidity again. Where are we? Safe math. Okay. Internal returns. So this is where it makes sure that the integers match and it doesn't do anything hunky with the math where it shouldn't be able to. Such as 10 divided by 0. Well, that's infinite. That breaks a calculator technically. So things like that. This is defining what math can be used, what can't, based on, see, like A minus B, A times B, A divided by B. Where are the variables okay, what's not? Oh, that gets so boring for you guys, but I didn't mind reading it because you know I love the math. All right, so even memory error messages handled. Everything's looking straight. Nothing pulls tokens out of your contract. Nothing leaves open. And you know you can revoke a contract after you've used it. Yeah, all right, continuing. Internal memory returns unchecked. Okay. A new function, because again, we're restating the program again. The Merkle proof. So here's the only issue I have heard, and I need a little clarification here, folks. So as far as I understand hash encryption, as I did 10 years ago before I decided to walk away from computers, basically you have a hash key. And then this hash key is your system state, and then through proof of work or through proof of stake, a mathematical equation is run, which creates a numerical value. That numerical value then is applied to that hash to alter that hash to move it along forward and creating a new link in the chain. The hash where it's been, the hash where it is, and then where it's going. So each time a system changes, a new hash gets added. The hash changes based on the new math, but you should be able to track back each section of that hash back to the token's origin. This is what makes encryption so great for blockchain. You can't fake it. Like, this is counterfeit proof. This is why. The hashes, the encryptions. I don't know a lot about this, so this is where I get lost a little bit. The Merkle Hash is what the blockchain encryption is called in this contract. It's a common one. Now, I will say, as much as I've read this and this contract looks safe, there was one discrepancy, which to me seems to make sense, but I don't know enough here. So please, don't like, don't subscribe, but comment. If you know anything about the programming here, please comment, because I'd like to learn more. I've put out my sussers for today. So the only issue is someone ran the test code on this software and found that the Merkle hash that was generated in their test software was different than the Merkle hash that was listed and published. And I wasn't sure if that was even an issue because hash tags change as the contract changes. They all have to be able to be divided and worked back and go back to that original hash, the starting value, but they all change. So am I wrong here to assume that the Merkle hash should look different being generated afterwards, and as long as it interfaces, the contract has recognized that it is authentic because it's the one that goes back through all the math proofs to see? I didn't learn the programming language, it's just how I understand it, so please correct me if I'm wrong. This contract to me looks 100% safe. You can revoke it after you put it into your MetaMask if you want to claim it. And the only discrepancy is the Merkle hash. And as far as I'm concerned, isn't that supposed to happen anyway? I'm really asking here. So if you'd like to come call me an idiot on my channels in Telegram or Twitter and discuss with me a little further the intricacies of programming security as I'm trying to actually apparently teach myself Solidity. Oops. I will not be your dev. Don't even ask. I hate programming. Hate it. I will not. That being said, if you'd like to discuss the functions of the Merkle root, how it actually is supposed to be used, how it actually functions, if I'm correct in my assumptions, or if somebody who actually knows how to use test software probably knows more than me. So that's all I wanted to bring today. Was I've read the contract. The contract appears completely safe. It's amazing how much actually happens inside that coin contract. I thought more of these functions were based in the Ethereum network and not in the particular functionality of the token. So I learned something new yesterday. That's cool. And I can read Solidity. And to me, this contract looks completely safe, but I do not know what the failed resolution between the published Merkle hash and the produced Merkle hash when running this contract really is. Thanks for tuning in for my Pulse Chain update with a little token. It just gets me mad when people get up on the FUD and they start screaming like, oh, this thing's a scam. Like, really? Did you read it? So, I thought I'd get out there and combat that, because I see these things in the chat. So I don't usually have an opinion. I'm not telling you to buy this project. I'm just telling you, if you're going to say something, you probably should do your research. And then I go and say a lot of things. So I will backtrack to price performance for PulseX. It is a uni DEX. And per my own calculations, Pancake Swap from its lowest dip to its highest peak had about a 220x. I'm not sure which swap was supposed to be a 300. This is something I learned months ago early on in chats from someone, not directly from a page. Trust, check your sources. So when I checked the information directly myself, like, okay, it was a little bit lower. But point is, the DEXs should be good for 100x throughout a year if they're decent, is what it looks like. So, I appreciate your feedback and comments. If I say something wrong, do tell me, because occasionally I get a number wrong, I get a fact wrong. I've only been here this year. I got here in November for Hex. That's when I started learning blockchain again. So, anything that happened before 2022, I might just get it wrong. And on that note, interestingly enough, I got to look this up. Lithiasis. It's an NFT project. Don't generally like NFTs. Useless rock art. This guy is making a comic book. Well, why is the comic book game going to be good? It's going to be a history of crypto. So, more of a drama comic book, like not a action superhero thing. Like, I'm not sure. So, this is interesting because, they want to... comic book series written and created by the DAO community. And they want to create a living history of crypto, especially around Richard Hart projects. Historical collecting data. It's actually harder to get historical data than you think. An historian. for crypto, for Bridget Hart specifically. I'm always skeptical of new people. No idea what this person's going to just steal the money, run away, or what, but the concept I like. So if they do it and they do it right, awesome. And if they don't, I think someone else should. So yeah, I'll be looking into this a little bit more. Anyways, thanks for tuning in, guys. Have a good morning and enjoy your weekend. Oh, yeah, that's right. If you made it to the end of the video, I forgot to mention earlier, I'm not a financial advisor. And Liquid Loans, if you go to their YouTube channel, Liquid Loans on YouTube, I'll be there today in about 6 hours from now. That's to say, yeah, they're having me on today. I have no idea what I'm going to talk about. Well, I have a little bit of idea. I don't know. Should be interesting. Tune in and check it out. 3 p.m. Eastern Standard Time, Liquid Loans. I might even be live. I'm a little nervous. Whew. All right, folks. You have yourselves a great day.